Okay, we are going to talk about a titration calculation now, and I have one written out on the paper here. We have 15.26 milliliters of calcium hydroxide. It's going to be titrated against nitric acid, and we need to find the concentration of the nitric acid. The point of a titration is to find an unknown concentration, usually of an acid or a base, although there are other applications that we can use titrations for. But this is the point of a titration, is to find an unknown concentration. Now, how to know that something is a titration calculation, that you need to do a titration calculation? There will always be some form of the word titration in the problem. It'll say titrated against, it'll say we titrate, or titration, or some form of that word titrating, but that will always be in the problem. So, how does this setup work? We put the thing in the flask, usually, that we don't know the concentration of. Not always, but almost always. The thing that you don't know the concentration of goes into the flask, and we put in 10 milliliters. Now, I used a pipette to measure it, and pipette is very accurate way of measuring things. It's very precise, so we're going to get our volume to 1/100th of a milliliter. That's pretty precise. Then we're going to put the stuff we know the concentration of, that's going to be my calcium hydroxide, into the burette. And I fill up the burette to the top, and then I titrate it until we reach the end point, and then I stop. And how do I know when we've reached the end point? Well, we also put a couple drops of an indicator in the titration into the flask, and the indicator will change color when we have reached the end point. In other words, when the base has neutralized all of the acid. What's our reaction in this case? We're going to take calcium hydroxide plus nitric acid, and we're going to form a salt and water. Water is one of the products. We're neutralizing the acid part and the base part and making water out of them. The other two pieces go together, calcium nitrate, and I put the formula down. I have obviously two nitrates here, so I need two nitrates on the left side, and that also takes care of the fact that I need two hydrogen ions to neutralize my two hydroxide ions, and that will make two waters. Two hydrogen ions, two hydroxide ions combined to form two waters. So here's my balanced equation. Now, the titration calculation, in order to determine my unknown concentration, is generally two steps. First step, we need to figure out how many moles of my unknown are in the flask. When we put in that 10 milliliters of nitric acid, we don't really know how much nitric acid was in there. We know the volume, but not how concentrated it was in the solution. So we're going to need two pieces of information. One we already know, we know the volume, but the other thing we need to know is the moles. So I'm going to start with the thing I know both things about. For my calcium hydroxide back up in the problem, I know two things. I know the volume, and I know the concentration. If I know both of those things, that's what I need to start with. So I'm going to start with 15.26 milliliters of calcium hydroxide, and I'm going to put in a conversion factor such that the milliliters will cancel. And let's look at that molarity. Molarity is moles per liter, right? Well, what is 1 liter? 1 liter is the same as 1,000 milliliters. So instead of writing 1 liter on the bottom, I'm going to change that to milliliters right here, just so that my milliliters can cancel. And I know that in 1,000 milliliters, which is 1 liter, I have 0.2615 moles of calcium hydroxide. My balanced equation tells me that calcium hydroxide and nitric acid react in a 2-to-1 ratio. And that's 2 moles of nitric acid to 1 mole of calcium hydroxide. And this is going to give me the moles of nitric acid in my original flask, in my 10 milliliters that I put in there. So I'm going to get a number, 7.9810 times 10 to the minus third moles of nitric acid. It's not really necessary that you calculate that intermediate value. You can just, or that you write it down. I'm sorry, you do have to calculate it. But you can just leave it in your calculator and then divide it by the next piece, which is going to be, we have 0.01000 liters of nitric acid, right? This is the volume. We just determined the number of moles, and we know that this number of moles that we've just determined is the number of moles that were neutralized by the calcium hydroxide. We know that they were in this volume, so if I would take those two numbers, 7.9810 times 10 to the minus third moles, divided by 0.01000 liters of nitric acid, they're both nitric acid, that will give me moles per liter. And I end up with 0.7981, and that's moles per liter. Since that's moles per liter, that's exactly the same thing as molarity. That's what molarity is, and there is my answer.